Hello guys, you're back with our next lecture. In this lecture, let us go through the second unit of Mathematics 1. So in this lecture, we'll be going through the unit called as infinite series, guys. Okay, so from this unit, there are only one problem, guys, but there are multiple methods to solve it. So basically, if one method fails, we'll be moving to another method. And based on the question format, you need to solve it, guys. Okay, so the terms which will be given in the question are whether it is convergence or not, whether it is a divergence, or whether it is absolutely convergence. So these are the three formats of questions which you can expect from this whole chapter, guys. Okay, yes. So first we will be discussing around, there are 9 methods, I think so, guys. Okay, just to give me a second, I'll be cross checking it because I count the number of videos, right? Yes, so there are total 7 methods. Okay, yes. So let us start with the first method, guys. If you understand how we are solving it, it will be really easy for you to solve in your examination, guys. Okay, yes. So without solving, I'll be just explaining you how you need to solve it, guys, because you will be getting a clear idea in this way, right? Because in the notebook I have written it step by step. That is the only reason why I am using the book here. Okay, so first is nothing but to identify whether a series is convergent or divergent. Guys, if you want theoretical concept for these questions, please check the classwork, guys. Okay, so this book which I am using is nothing but the short notes, and in classwork there are everything in detail, guys. Okay, yes. So whether a series is convergent or not. Okay, so basically whenever you apply limit n tends to infinity, if the value of that particular series you got as a 0, then you will be saying it as convergent. If you got any other number than 0, it is a divergent, guys. Simple trick. Okay, yes. So now let us go through the first method. First method is nothing but the basic method where the maximum power of both numerator and denominator is equal. So x value is the same in the both numerator and denominator, n power x. Okay, so here just by observing the example, can you say whether they are equal? Yes. So if in your examination, if you found this as an example, you can directly solve it because both the powers are same. You'll be moving on with the first step. Okay, so the first thing that you will be doing is you will be writing the same question given sigma, okay, 4n cube plus 2 by 7n cube plus 2n. Okay, so after that you will be writing this as un is equals to 4n cube plus 2 7n cube plus 2n. Okay, as you know, we apply limits on both sides. Limits n tends to infinity, limit n tends to infinity. Okay, so from both numerator and denominator we can take n cube common and cancel it out, right? Yes, and inside what will be there? 4 plus 2 by n cube. So basically something by infinity, so 2 by infinity. So few of you might be confusing that, okay, so I'm confused always whether it is 0 or infinity, right? Yes, so for your basic understanding, instead of infinity take the maximum value which you can take, guys. So assume that 2 by, okay, so if this is the value, it will be 0.0002, right? So in this way it will be 0.000. So indirectly it is approximately equal to 0. In that way you can remember. Okay, yes. So sometimes even I confuse, so this is the trick which I use to recall. Okay, yes. So once you apply the limits interiorly, it becomes 0 0, right? Yes. So 2 by n cube is 0, 2 by n square is also 0. Okay, so limit n tends to infinity, un is equals to 4 plus 0 by 7, right? Yes, so we got 4 by 7 which is not equals to 0. Hence you can say that the given series is a divergent, guys. Okay, so note that the first step is applied, the first method is applied only when the powers are same, guys. Okay, so let us go through one more example. So here the powers are same, that is nothing but n power 4 and n power 4. Okay, so we solved it in the same method. Again we took n power 4 common, and here we got 1 is equals to 1 not equal to 0. Hence it is also divergent. Okay, so for more examples you can check the classwork, guys. So here also it is power 3 as common, here power 2 is common. Okay, okay, so here power 1 is common. Okay, so here power 4 is common. Okay, here, okay, yes. Okay, so in this way you can continue, guys. Okay, so I hope everyone got a clear idea. So here you might be confused that it is 2 power n plus 1 by 2 power n. So here it is different, you might be assuming. So basically it is nothing but 2 power n into 2 plus 1 into 2 power n minus 3. So basically power is same, guys. Okay, yes. Okay, so that's what it's written here. Okay, so similarly you can continue. Okay, yes. So there are various examples in the class, or guys, you can check each and every one. Okay, yes. So I hope everyone got a clear idea on this. So in the next lecture we will be moving on to P series test, and in which we will be moving on to comparison test, guys. Okay, so let us meet in the next lecture. Thank you, thanks for watching.